What's up, honor students? Today we are going to be calculating limiting reactants. To do that, let's take a look here. We have our ham sandwich recipe. If you combine 6 breads with 2 hams, how many sandwiches can you make? The answer is 2. Okay, so the reactant that produces the least amount of product is the limiting reactant. In this case, the limiting reactant is the ham, right? It limits how many sandwiches can be made. We have extra breads, so we're going to consider that the excess reactant. You can determine the limiting reactant by determining the amount of product that each will form. So let's jump into these practice problems here. 19.9 grams of copper oxide react with 2.02 grams of hydrogen. What is the limiting reactant? So we're going to convert both of these to moles of product. Which product? Well, if I read ahead, it seems that they're really interested in copper here. So I'm going to convert to moles of copper. So first, I want to divide both of these by their molar masses. And then I'm going to multiply by the mole ratio. I'm going to do this all in one step here. And again, we're converting to moles of product. We're trying to see how much copper each of these can produce. And so for our first reactant, that copper oxide, we get 0.25 moles of copper. Meanwhile, with the hydrogen, we get 1 mole of copper. So the limiting reactant, again, is the one that produces less product. In this case, the copper oxide is the reactant that produced less product. Next, what is the theoretical yield of copper? So we can take the actual amount of copper being made, right? So the limiting reactant tells you how much product we're actually going to make from this reaction. And we can do the last step here, which is just to convert it to grams of copper, multiplying by the molar mass, and we get about 15.89 grams of copper that's going to be made theoretically. All right, another follow-up question you may see is to find the percent yield. So in these problems, they give you the actual yield, and we can divide that by the theoretical, multiply that by 100%, and you can punch that in your calculator yourself. Okay, so I'm going to move on. Feel free to review that first problem. We're going to do another limiting reactant problem here. So here I've balanced the equation for you. 64 grams of both reactants react together. What is the limiting reactant? What is the excess reactant? So again, same steps. We're taking grams of reactant. Both reactants in this case have 64 grams. And we're going to convert it to moles of product. Which product should we convert to? Here it says C2H2, so I'm going to convert to C2H2. Again, first step, divide by the molar mass. Here I'm rounding off the molar masses just to make it a little easier. And then again, the second conversion is going to be multiplying by that mole ratio to get moles of product, in this case C2H2. So, got to be careful with the water. There is a 2 for water. If I look at my chemical equation, it's highlighted here. And then for calcium, CaC2, that's still 1 mole. Okay, I punch this in my calculator. And I get 1 mole of product for the first reactant. My second reactant produces 1.78 moles of this C2H2 product. So the limiting reactant, again, is the one that produces less. That's going to be the CaC2. Meanwhile, the excess reactant is going to be my water, H2O. And those are the answers Okay, so again, if we wanted to find the theoretical yield, we would simply take the moles of product, the lower amount of moles of product, and do a final conversion by multiplying by the molar mass here. You can calculate that yourself. It's pretty straightforward. The last kind of problem you'll see is this number 3 here, is how many grams of water are left over from this reaction. So now that we know how much product we're making, we want to see, well, how much water did we use to make that? So we're going to actually kind of work backwards here. We're going to take that 1 mole of product, and we're going to try to see how many grams of water we actually use in this reaction. So I have to convert to moles of water before I can get grams of water. So we're going to do a mole ratio conversion here. Again, these numbers come from the chemical equation. We get 2 moles of water, but again, we want the grams of water, so I'm going to do one more conversion to get my moles to grams, and that gives me 36 grams of water are used in this reaction. However, this question is asking how much is left over. So we had started with 64 grams of water here. So we're going to take that 64 grams of water and subtract the 36 grams of water that were used, and it turns out we end up with 28 grams of water left over from this reaction. And that is going to be my answer. Okay? So that's how you do these limiting reactant type problems. Those are all the different kinds of problems you might encounter for limiting reactants. I hope this video helped you. Make sure to like and subscribe.